Hey, this video is for anyone who missed the LightTools user group meeting in September 2020 where I spoke and gave this presentation. I'm doing it again as a more public thing because I got some feedback that people wanted to see it or hear it, but they're not Synopsys customers, or they're not LightTools customers right now, so they can't get into the portal. So here's this one. I'll try to tailor it more for people who maybe aren't familiar with Synopsys LightTools. My name is Erin McDermott, and I am Director of Optical Engineering at SpireStarter.com. So, the title of this presentation was Blowing Hardware Startup Minds with LightTools, because that's a lot of what I do now. Instead of working in a large corporation where there's a job that's maybe been there for a long time for optical engineering, I'm now predominantly working with hardware startups that don't even know what optical engineering is before I get there. So things that I thought were commonplace, things that I take for granted, especially within LightTools, are often amazing to these people, and it's also applicable even if you're not working with hardware startups, and I'll try to explain that as we go along. So let me first explain Spire Starter's weird business model. So primarily we work in optical engineering services, and we work with a large network of freelancers. So that way I can come to a company and be able to offer them lots of different specialties and lots of different industry experience, even though I only myself cover a part of the pie. A lot of times these clients are hardware startups, as I mentioned, and a lot of them bring similar problems which require a lot of hacks. So let me just say right here that I am not proud of a lot of the things I'm about to show you. I completely understand that they are not the right way to be doing things, but when you're given a limited amount of time to come up with some sort of feedback that can direct a client, that can direct a small company before they freeze their engineering design. You know, maybe they have 2 weeks and they come to you and they're like, well, is this going to be better? Is this going to be better? And you can't go back to them and say, well, you really should have a RAW file for your LED. Well, you really should have this material characterized correctly. You know, they would just say like, well, we don't have time for that, so thanks anyways. So to give them something, you have to make some hacks, and that's what I do a lot of the time. And a piece of my optical engineering self dies each time I have to do it. So to give an example of the types of things that I might have to hack these days with hardware startups, a lot of consumer electronics that I'm seeing are using something like this. This is Core's Wellness Meditation Trainer. I use them as an example because it's already public knowledge that my company has done work for them. We got them a feature in SolidSmack.com talking about how they engineered a lot of the parts of this physical product, which was amazing. I'll link to that underneath this YouTube video so that you can check that out if you're interested. But this plastic that you're seeing that's backlit, that's like a diffuse random plastic, that's common. It's very common now. I see it all the time, and it's one of the most common things that I work on now, actually. It's really surprising that companies are willing to pay just as much for, you know, regulated headlamp design that's really difficult to do as they are to clean up some beautiful lit effect on a consumer electronic. So the rest of what follows may or may not have to do with this specific design. It's just an example of the types of backlit diffuse materials that I see all the time. So I already mentioned this, working with hardware startups is kind of fun because things that I think are simple blow their minds. And you know, just like blowing bubbles in front of a child, this is my surrogate niece here. Like to you, it's like, yeah, it's just bubbles, but the kid's like, whoa. And it kind of feels like that a lot of the time. It's not a bad thing. That part, at least. So how is this maybe important for you to know in your situation, even though you're probably not working with hardware startups like I am? Hopefully you're not having to do the hacks that I have to do on a regular basis. The thing is, the people I'm interfacing with are a lot like the other disciplines at your job, the other people in different departments, in your electrical engineering department, in the mechanical engineering department, in the lab, even on the programming side. These people are technical, they're working on the same project with you, but you know, they don't actually know how your software works, they don't know what your job is, they don't know how you do what you do, and they don't know what you're capable of either. So I think it's very beneficial for optical engineers to reach out to these different people and show them what we can do. In the past, the fact that some of my coworkers didn't understand what I did led to some serious problems. They didn't understand that I created a model, a fake model of the real world on my computer, and that took some time to develop, and then I shot rays through it, and then that also took some time to happen. I don't know what they thought that I did, but they didn't understand that was part of the process. So in one case in particular, I had an engineer go behind my back and say that I was lying about what a timeline should be, and it was not good. So in that case, I had to like sit the person down and be like, do you understand this is what I do and this is how it works? And he said, oh no, I didn't know. I'm like, okay, well, glad we had this talk. And even if that's not the case where you work, and I hope it's not, just letting other departments know things that you can do is super helpful to helping the progress of the development itself, whatever you're working on, right? Because if you have some people working in a lab and they're trying to figure something out, and they don't know that that's something really easy for you to figure out with a simulation, then they might be, you know, beating their head against the wall for a while and not realizing that. But I also understand that you're not going to want them to come to you for every little thing either. So let's start out with something simple that you can show them that you can do. If you're using LightTools especially, because I've had to do this in other software and it wasn't as easy. But if you are ever using LightTools, you can show them this and it will blow their minds, okay? Straight line analysis. You might not call it straight line analysis if you're working on an illumination system, but it's basically the same thing, right? You're doing some non-sequential ray tracing. You're trying to figure out the source of some extra light, or you know, it could be a little too much light that's pushing a test point just beyond its tolerance, or it could be just there should be no light at all at this point and you need to figure out the places where it's all coming from. That is ridiculously hard to do on a bench, right? So if you just light something up in a bench and you turn off all the other lights and you try to figure out, okay, I see the spot of light and I don't like it, but where is it coming from? And what can we change to make that go away? That's really tough to do. But in LightTools, it's a lot easier. So here's a not real example. I apologize, I threw this together because I didn't have enough time to actually come up with a real example, and I couldn't use any of my like clients' CAD, obviously. So I just created, I don't even know what this shape is, some sort of shape with a hollow center, and I stuck 3 LEDs inside, and then this blue like semi-circle, semi-hemispherical, I don't know, it's half of a ball that's cut out here. That, we're gonna say, is a part that the client does not want any light in, that it would be really bad if that lit up. So you know, maybe they prototyped it and there is light, and they come to you and they're like, okay, well, we don't want this here. What do we have to do to get rid of this light? Now, that could be a really hard problem if you are working in, say, ASAP. I talked with someone recently who is using ASAP for stray light analysis to verify, like, y'all still doing it the way you used to do it? And he told me that there is a way in ASAP to take a region on your CAD, I guess, but it has to be a planar part of your model. It has to be flat, right? And then you can define a region, and I think you probably also have to have it lined up with some axes. I'm not sure. But you don't have to do that in LightTools. In LightTools, it just needs to be a separate surface, a separate entity in your simulation, and then you can slap a receiver on that. Super simple. What was I going to say? Oh yeah, so previously I used to use ASAP for this, but we had to do some weird stuff with like reverse ray tracing. So we'd shoot all the rays through first, and then we'd capture the ones that landed where they weren't supposed to be, and then we take that and reverse ray trace it, and then see where the rays were real and where they were fake. We'd have to like cut out all the other stray rays in Rhino and delete them like one by one. It was ridiculous. It took several days to do this, and in LightTools I can do it in minutes for most things. Not for all things. It depends on, you know, how many LEDs you got going on and how big your model is, of course. But it's in any case, it's way simpler than what I used to do years ago in ASAP. So you just slap on a receiver. Just slap it on. I think you just right click on the part in the model, or you can go to the tree, add a receiver, and then, you know, make sure you got some bins in there and tweak it a little bit, but there isn't much you need to do to just get some rays collected in that specific region. You have to make sure that, you know, those rays going to that receiver are collected, but really it's just a couple more checkboxes to make sure that you're going to see what you need to afterwards. It's not several days worth of messing around. It's not at all. So in this simulation of this horrible model, I'm so sorry, you could see that the rays coming through, there are these different colored squiggly lines on the right here going up to the half ball up here. And I should say, by the way, let me go back to the original picture. So this, the dark blue here, this was a false color plot. So the blue is 0 light, and then the red is maximum intensity, and then, you know, green's in the middle. So that hot spot there, we can see now is at the bottom, and we see other rays on the other side, but that's not really as visible. So maybe the customer only cares about this hot spot on the right side. And, you know, it's pretty easy to see which well, not easy for you because I didn't really label these LEDs, but there are 3 LEDs here, and there's one on the right side, and it's pretty clear to see that that LED is the culprit, right? The ones coming, the rays coming from the right side of that LED are contributing the most to that hot spot up there. So if we maybe shielded that one, or if we cut down the intensity of that one LED and bumped up the other 2, you know, there's several different possibilities for how you could fix this going forward based on this little bit of information. And you can find it very fast, and above all else, it's very easy to translate this to your compatriots on the other silos, right? It's visual. You can see, you can understand it. You know, a picture like this really is worth 1,000 words, especially when you have to explain things to people who aren't doing what you're doing. So another example would be, and again, this is a horrible, horrible model. I just made some shapes and had some rays pass through them so that, you know, to give really a rough idea to people who use LightTools what you could do. But, you know, say you have this luminaire and that's this cylinder thing at the top. That's what it's meant to be. And you got a source inside there. And maybe the product manager doesn't like that there's some glare at this specific angle when he walks in this specific direction and this specific distance away from the luminaire. Maybe he doesn't like that it's blinding him right there. So you figure out about how tall that product manager is, where his or her eyes are, and you can kind of figure out about what angle is the problem angle, and you can create some sort of surface there. It can be, you know, a dummy receiver. You can just slap some CAD in there of something else and slap a receiver on that just like you did everywhere else. That's what I do because I'm just used to doing that. And then just like for the last one, you just trace rays to that part which represents the problem area. So even though there is an existing CAD that you're trying to identify, like that's being lit up and you don't want it lit up, you know, you can create CAD, or you can create a dummy receiver in a place where you don't want light. And the same would be true for, you know, if you have an automotive headlight and you don't want light in a certain region. So actually for that, I just recently subcontracted to someone who's using Lucid Shape, but I still have LightTools. I'm not going to go out and buy 2 different software packages. So it's cool that I can still analyze that design in LightTools, even though I wouldn't probably want to design a headlamp in LightTools if Lucid Shape were available to me. But anyway, moving on. So another big problem that, okay, so this one even this one even mystifies me that it can be done. Okay. The other one was blowing hardware startup minds. This one blows my mind. So with these diffuse materials that are being backlit or kind of used as light pipes or something like that, it's not a light pipe, but they think it is. So let's just let them have that. So these materials are typically a clear base plastic, so PMMA or PC, and they mix some titanium dioxide, TiO2, in there, and there are these little white particles, and the more particles and the different, depending on the size of the particles, you get different levels of diffusion in that part. So the good news is this can be modeled in LightTools. The bad news is you really need to know exact parameters about how that material was created. Very specific, in order for it to be a really great model in LightTools. And that is usually hard to find because it's usually mixed in a Chinese garage. A little of this and a little of that, and no one really knows for sure what these materials are usually made of. And the other bad thing about when these materials are used is that it's usually too far along in the process when I get involved that for there to be time for them to send out material to, say, Light Tech in Europe and get it measured and have a model created for that scatter, that volumetric scatter. And without that, like, what are you gonna do? So There is a really great paper that one of the engineers within Synopsys created for this. Mike Zollers is amazing. He helped walk me through this, I think, might have been last year when I first started playing around with this functionality. But since you're probably not a LightTools user, maybe you don't care, but if you do end up getting LightTools, just know that there is a paper to walk you through this step by step about how to build these diffusive materials. The required inputs are, you need to know about the base plastic, you need to know, is it PC, is it PMMA, get the exact refractive index over wavelength, and the absorption over wavelength, sorry. With the titanium dioxide particles, you want to know the refractive index over wavelength, the absorption over wavelength, and the particle size distribution. So you want to actually know how big to how small the particles can get. And then you have to know about the mixing condition. How were these two components mixed together? Option 1 is with particle number density, so the number of particles in 1 cubic millimeter of material, the number of titanium dioxide particles, I mean. Or option 2 is the volume fraction, percent of the volume that is particles versus the percent of the volume that is base plastic, or by a weight ratio. The limitations are kind of sad. So there's this really cool thing called photolit rendering in LightTools, and for a lot of things you can get a very realistic looking simulation of what some lit object would look like in real life. But it doesn't work with volumetric scatter, which is what these titanium dioxide mixed into PMMA or PC are. So instead, you have to go through a process. The good news is it still does work. The bad news is it takes a very long time. You have to create a backward spatial luminance mesh over the area that you want to see, and then create a virtual camera, and there's a whole process for that too. So in my case, when I figured out that I couldn't actually deliver the photolit render that I had promised my client, I did do the backward spatial mesh trace, and it wasn't perfect. It was a good approximation for, because I also had to guess at the particle numbers and density and like all of those parameters that I just explained to you. I had to kind of like guess at all of them. And, you know, Mike Zollers, he warned me not to do that, but I didn't really have anything else to work with at that point, so I did. And then in the end, it had a similar diffusion in terms of how much light came through, I guess a percent transmission, but the color was a bit off, so I think the absorption over wavelength for maybe the base material? I don't know, something was not right with the color. So we ended up having to ditch that for the pretty lit rendering part, but what was cool was, so wait, let me back up. Well, this is like a really low resolution example of what you can do with the backwards spatial mesh trace. This is those 4 different thicknesses of diffusive material over top of a light source. So I don't even know how many rays that was. It was probably a lot, but for this type of trace, I needed to let it run at least like 5 to 7 days straight. without my computer crashing. So that kind of made it infeasible for me in a very short amount of time, because with this client, just like with most of them, I wasn't getting enough time to do this properly. So there wasn't enough time for me to like, okay, well that wasn't quite right, let me tweak it, and then run it again. You can't do that multiple times, right? So what I had to do was just kind of go forward with looking at the false color plots for most of the stuff. And for that part, it was very similar. Like, I was able to look at relative changes to the appearance based on different tweaks and see, would this make it better or worse? You know, like when you're getting your eyeglasses, like camera 1, camera 2, camera 1, camera 2, lens 1, lens 2, A or B. It was about like that. I mean, those are all still very useful pieces of feedback to get when you are ready to freeze a design. You know, just trying to narrow down between an array of options what your best option is. Sometimes that's the only real feedback that you can give as an optical engineer that's worth anything, that they can actually use. So for that, it still worked, and again, I was able to blow some hardware startup minds, and my own too, because I was like, oh my god, it worked. Rabbit out of a hat. But if you have more time to work on your model, then that's cool. You can make sure that you have all those little nitty-gritty details about the material before you get so close to the end of the design cycle that you can't actually model it correctly anymore, right? Like, you can make sure that those pieces of data are being recorded and actually kept track of on your vendor side, if it's your vendor who's specifying the material. Or, you know, a lot of times you just know that you can't rely on on that data, so instead you at least know that you will have time and you can plan ahead to have those materials sent out to be measured so that you can get your your scatter model sent back. And so just another way that I would kind of use to communicate and kind of as an extra check of what I was doing when I'm making these just hacked scatter models would be to look at Lexan has some optical grade diffusive materials that were actually really measured, and they will tell you you have to really hunt for the data sheet, but it's out there. Not through SABIC, but there is a SABIC data sheet online, and it will tell you thickness and percent transmission for different mixes. And so for that, you can, and also these are already, many of them are already in the library for LightTools. Excuse me, for the material models. So you can, just slap in one of these library materials that you actually know what the percent transmission is for different thicknesses, and as like a cross-check for yourself. And then if you need to communicate what type of material might work better in your client's case, or what the preferred transmission would be, then you could say, here it has to be similar to this model, which I simulated, and it gets me this result, and so that should be about half of the light should be coming through if it's in the parts that are 3 millimeters thick, and that's it's a much more translatable definition of diffusion to other departments once again. So I find that's very useful for a lot of different things, and I'm typically going back to these Lexan grades, even if my client can't end up using them, at least so they know it's some sort of standard. right? Some sort of material that's out there somewhere in the world that actually has definable properties. So yeah, that was my presentation. Again, I feel terrible about how much I have to hack these models. This is not the right way that you should be doing any of this stuff, and there are definitely types of optics that I would not even think about doing this for, that I wouldn't trust any of the feedback that I would, give someone, like say IR sensors or something like that, where the actual quantities matter a lot, and it's not just an aesthetic thing that you're trying to perfect. If it were if it were something where things are really on the line, I wouldn't be relying on these types of methods at all. I would be more dead set on pressing back on the customer to, you need to get these measured or else I can't give you any sort of real feedback. But for these types of things, it actually works. It works enough to give some sort of feedback before the trigger's pulled on a design freeze. And sometimes, actually most of the time, that's all that I have to work with to help my clients. And some good feedback is better than no feedback at all. Yeah, I hope you enjoyed that. I hope you can still see me even though the sun is set and my lighting in here is terrible. It's not my house. It's not. So. Is that better or worse? I think it's worse. Well, thanks very much for watching, and yeah, if you have any more questions, you can contact me at the contact page on spirestarter.com, whether you are an optical engineer or you need optical engineering services, or you're some other type of engineer that's thinking about going freelance. Let me know. Bye!